Now let us see another reaction of ethanoic acid, and that is reaction of ethanoic acid with sodium hydroxide. On treating with sodium hydroxide, now sodium hydroxide is what? It is alkali. It is a base, right? So when there is a reaction between ester and sodium hydroxide, what happens? This ester is converted back to alcohol and sodium salt of carboxylic acid is formed. So this is reversible reaction. Okay, what happens before that? Ethanoic acid and ethanol forms ester. If we take ester and sodium hydroxide, then again it is converted into sodium salt of carboxylic acid, and this is known as saponification. You need to remember this process, what it is. Saponification, which is used for making soaps. Let us once again understand. When there is a reaction between ester and sodium hydroxide is a base, then reaction between the two gives us sodium salt of carboxylic acid, and this process is known as saponification. It is used in the preparation of soap. Soaps are sodium or potassium salts of long chain of carboxylic acid. So whatever soaps we use, that are of which group? They are of carboxylic acid, and they will be salt of either sodium or potassium. So soaps are generally sodium salts or potassium salts of carboxylic acid. So this is all about esterification and saponification. Now let us understand the next reaction of ethanoic acid. Reaction with a base. We all know that sodium hydroxide is a base. So what happens when ethanoic acid reacts with sodium hydroxide? Ethanoic acid reacts with a base such as sodium hydroxide to give a salt, and it gives salt like sodium ethanoate. General name of sodium ethanoate is sodium acetate. Also it gives water. So what is reaction of ethanoic acid and sodium hydroxide? It gives a salt, and the name of salt is sodium ethanoate, or else we can say it as sodium acetate. Sodium acetate is common name of sodium ethanoate. Also it gives water. So here we have reaction with base. Last reaction, NaOH, that is sodium hydroxide with CH3COOH, that gives CH3COONA, that is sodium ethanoate. Formula, chemical formula of sodium ethanoate or sodium acetate is what? CH3COONA, and water. Now the next reaction of ethanoic acid is with carbonates and hydrogen carbonates. For that, let us understand an activity. Here we have to set the apparatus which we have used for chapter 2 also in activity 2.5. Like this, we'll take all the apparatus and we'll take a setup. What we have to use here for this activity? We will need a spatula full of sodium carbonate. Here we'll learn reaction of ethanoic acid with carbonates. So we are using sodium carbonate. So in a spatula we have to take sodium carbonate, and in a test tube we have to add 2 ml of dilute ethanoic acid, which is not concentrated. It is dilute ethanoic acid. So, as shown in the figure, in this test tube, we will take this dilute ethanoic acid. And then we have to pass the gas which is produced freshly prepared lime water. As a result, we will observe that it forms salts of carbonates or hydrogen carbonates. Here we have taken sodium carbonate. So which type of salt it will form? Sodium ethanoate or sodium acetate. Common name is sodium acetate and chemical name is sodium ethanoate. So here we have reaction with carbonates and hydrogen carbonates. So when we take reaction between ethanoic acid and sodium carbonate, what does it form? It forms sodium acetate or sodium ethanoate, and also it forms water and carbon dioxide. Here we have reaction with carbonates and hydrogen carbonates. Let us understand these reactions. In first reaction, we have ethanoic acid plus Na2CO3. Na2CO3, that is sodium carbonate. And what does it form? It forms sodium ethanoate plus H2O water plus CO2 carbon dioxide. Let us see the second reaction. That is ethanoic acid plus NaHCO3. NaHCO3 is sodium bicarbonate. Remember this, Na2CO3 which we used in first reaction, that is sodium carbonate, and in second reaction we have used NaHCO3, that is sodium bicarbonate, and that also gives rise to sodium ethanoate or sodium acetate plus H2O water plus CO2 carbon dioxide. So these are the reactions of ethanoic acid with carbonates and hydrogen carbonates. Now remember these two examples which we have used for carbonates and hydrogen carbonates. For carbonates we have taken sodium carbonate. Remember the formula Na2CO3, that is sodium carbonate. Also it says to take hydrogen carbonates. So which hydrogen carbonates we have taken? NaHCO3 hydrogen carbonates, which means in the formula H will also be there. So what is the formula? NaHCO3, that is sodium bicarbonate, which is from the group hydrogen carbonates. So these differences between carbonates, hydrogen carbonates, and the examples which we have taken, sodium carbonate and sodium bicarbonate, that you need to remember. In both the cases, which product is formed? Sodium acetate and water and carbon dioxide. So here we have completed properties of ethanoic acid. We learned physical properties also, and we learned chemical properties of ethanoic acid by learning different reactions.